Welcome back. This is the video for day 7 of Advent of Code 2025. For this day, the input looks like this here. We've got this grid with an S at the top, so S stands for source. So this is a source of a beam, is what it says here, and the beam propagates downward, and when it hits one of these carets or splitters, then the beam goes to either side, right? But doesn't go directly down. So it just does that over and over again until it hits the bottom. And they show here what that would look like for this input. So the pipe symbol here represents the beam. And so you see it hits the splitter here, then it goes to either side, and then it keeps going down, and then it hits some more splitters, and so on until it hits the bottom. And for part 1, they want us to count how many times the beam gets split, basically how many times does the beam hit a splitter, right? So in this particular input, for example, there are 22 caret symbols, and only one of them does not have a beam that hits it. So the answer for part 1 here is, or for this example input, is 21. So let me show you the full input they give us. So that's just what it looks like. Let me maybe zoom out so you can see the full thing. It looks like a giant Christmas tree, basically. And we've got our source at the top, and then we've got all these carets, which they call splitters. And so we want to know how many of these get hit by the beam, basically. So that's the question for part 1. Now, in terms of code, my initial solution worked, but it was a bit messy. So I found online that there's a better approach, and that's what I'll show you here. The approach is to basically keep track of the indices of where the beams are line by line, and kind of update line by line, right? So for the first line here, we've got S at, well, it's at index 70 here, which is what I find with this line of code here. And then what we do is to, at every line, create a new dictionary that updates the indices of the beams, basically. So let me show you what that looks like in code. So we can do for line in lines, and we're going to start at the second one at index 1. And we're going to create a new dictionary of indices. So beam indices new equals, and we'll use the default dict here. And then we're going to check for every index in, what is it? In, well, in beam indices. We're going to check if we hit a caret or not, basically. So we're going to match line IDX to see if it's a caret. And if it is, then the new indices will be to the left and to the right of the old index, basically, right? So it's going to be beam indices new IDX minus 1 equals to 1 or whatever. It doesn't really matter what the value is here. And then also plus 1, right? So that we have the beam on either side of the caret, right? And then if it's not a caret, then we just propagate the beam. So beam indices new IDX equals to 1 as before. And then we'll update our beam indices variable to be the new one. Sorry, I forgot the equals here. And also, if we hit a caret, we can increment a part 1 variable here, which I'll initialize at the top. And then we can print out part 1 here. Oops. There we go, 1600. So that should be the number of times the beam is split for part 1. For part 2, they want us to calculate how many different beam paths there are from the source all the way to the bottom here. So that is going to be a large number because every caret essentially doubles the number of paths to the bottom, right? Now, the code changes needed here are fairly minimal, actually, because we can use the dictionary values to keep track of the counts. And so for part 1, we could have actually used a set and not a dictionary or a default dictionary. But I knew part 2 was coming, right? So that's why I've created a default dict here. So all we need to do is, well, let's see, we're going to do index and count in the dictionary.items, and then the value associated with each key is going to be the count of ways to get to that particular point, basically, for the beam path. So all we need to do is do plus equals a count, right? And I'm going to run all here, and so the final answer, to get the final answer, we need to look at the values of the final beam indices. So we're going to do beam index or beam indices values, and then sum those up. And going to run all here, and that's the answer for part 2. So hopefully that's comprehensible. Let me know if that's not clear in the comments. Thanks very much for watching, and I'll see you in the next video.